Hi everyone. In this section, I'm going to introduce vector-valued functions and space curves. Let's start with the vector-valued functions, or in short, vector functions. A vector function is a mapping from a set of real numbers to a set of position vectors in ND, in which n is greater than or equal to. Each t as a member of domain is imaged to a position vector which is formed by n components like r sub 1t, r sub 2t, and r sub n t. Each component is a real valued function or a scalar function, which is called component function. To find the domain of a vector function, it is enough we find the intersection of the all component functions domain. For example, if d sub 1 is the domain of the first component, d sub 2 is the domain of the second component, and d sub n is the domain of the nth component. The intersection of these n subsets will be the domain of vector function. Look at this example. Suppose R is a vector function from R to the 3D, and R of t is equal to square root of t 1 over t minus 4 and e to the t. This is a vector function which images each real number to a position vector in 3D. To find the domain of this function, it is needed to find each component's domain. The square root of t is defined for all real numbers which are greater than or equal to 0. This fraction is defined for all real numbers except 4 as a root of denominator. And e to the t is defined for all real numbers. Okay, the intersection of these three subsets will be all real numbers which are greater than or equal 0 except 4. Now suppose R is a vector function which is equal f of t, g of t, and h of t. If we set x is equal first component f of t, y is equal second component g of t, and z is equal third component h of t. This form is called vector function's parametric form. And if we can find a relation between x, y, and z in such a way that t is omitted, the equation which is written just by x, y, and z is called Cartesian form of vector function. Look at this example. R of t is equal to cosine of t, 2 sine of t in brackets, or we can show it by I and j, 2 cosine of ti plus 2 sine of t j. If I set x is equal the first component, 2 cosine of t, and y is equal the second component, 2 sine of t, this form is called the parametric form of vector function. And look at this here. X squared plus y squared is equal 4 cosine of t squared plus 4 sine squared of t. By pulling 4 out, we have cosine squared of t plus sine squared of t, which is equal 1. Therefore, x squared plus y squared is equal 4. That is a circle with the center of origin and the radius of 2. This form is called Cartesian form of this function, which is written just by x and y. The next part is about the space curves. The question is, what is the shape of a vector function? Okay, we start this part by this example. R of t is equal to cosine of ti plus 2 sine of tj. To find the shape of this function, we plug in different real numbers. First, we plug in 0. R of 0 is equal to cosine of 0 I plus 2 sine of 0 j. Cosine of 0 is 1, sine of 0 is 0. So this is equal to I. Okay, it's needed to have xy axis, x axis and y axis. Okay, 2I is this vector. Then we plug in pi force is equal, R of pi force is equal to cosine of pi force I plus 2 sine of pi force j. Cosine of pi force is square root of 2 over 2 I plus 2 times square root of 2 over 2 j. By simplifying, we have square root of 2 plus I plus square root of 2 j. Okay, that is this one. Then we plug in pi. R of pi is 2 cosine of pi I plus 2 sine of pi j. Cosine of pi is negative 1, sine of pi is 0. It is equal negative 2i. Negative 2i is this one. As you know, there are a lot of real numbers, and for each number, there is a position vector. By connecting the end of position vectors to each other, a directed curve is traced. That is, here is a circle with the center of origin and the radius of 2. So the shape of this function is a directed circle. Now let's see another example. Suppose r of t is equal to cosine of t, 2 sine of t, and t. To find this function's shape, it is needed we plug in different real numbers. But before that, we need to draw XYZ axis. Now, first plug in 0 is equal to cosine of 0, 2 sine of 0, and 0. 2 cosine of 0 is 1, sine of 0 is 0, and 0, which is equal to 0, 0. That is this vector. The next one, we plug in pi second. 2 cosine of pi second, 2 sine of pi second, and pi second. Cosine of pi second is 0, sine of pi second is 1, so we have 0, 2, and pi second. 2 on y-axis and pi second on z-axis. By connecting these two lines, we have this vector. The next one, we plug in pi. 2 cosine of pi, 2 sine of pi, and pi. Cosine of pi is negative 1, sine of pi is 0, so we have negative 2, 0, pi. Negative 2 is here and pi is here. That is this one. Again, since there are a lot of position vectors, by connecting the end of these position vectors to each other, a directed curve is created. That is, here is a spiral. As you see, since the vector function's image is in 3D, the curve is traced in the 3D and is a spiral. But if we look at it from the top, we will see a circle with the center of origin and the radius of 2, because the first component and the second component are look like the previous example. And as you see, the shape of this example was the circle with the center of origin and the radius of 2. But the difference is in the third component. By increasing t, the height of the height of curve increases too. So it makes that this directed curve is not smooth or in the plane. It is a spiral. Okay, here is the end of this section. See you soon.